So up until this point, I've sort of made it seem like use substitutions and integration by parts are mutually exclusive sort of methods. But that's not actually the case. Sometimes you run across integrals where you have to use them in combination. And I'll give you an example of how you might do that. So what if we had the integral of ln of x squared? Well, at first glance, you might not know what to do with something like this, right? You could do a u substitution for ln of x, right? U is equal to ln of x, but then when you do your du, then you run into a little bit of a problem because x doesn't go away. You have 1 over x dx. And so when you substitute ln of x for u there, or u for ln of x rather, your dx is going to be x du, right? Basically, if you want to sort of rearrange this thing right here to see what dx equals, right? Because you got to substitute that dx. If you multiply both sides of this equation here by x, you get that dx is equal to x du. And so that is a problem because you get, if you did the whole substitution, you're going to get something like this. You're going to get, u squared, right? Because ln of x is u. And then when you put in your du here, you have this x that tags along. And that appears to be a problem, but actually we can solve it by solving for what x is. So here, if u, and we solve for what x is in terms of u. If u is equal to ln of x, and we want to solve for x in terms of u, well, we have to take the anti-log of both sides. So essentially, if you raise both of these, e raised to both of those powers, you get that x is equal to e to the u. And so substituting that in, we come up with this integral. The integral of e to the u, times u squared du. And this, I hope, well, maybe the order I wrote it in might not look familiar, but this is, just a power function multiplied by an exponential, and we know how to solve these. And actually, it's raised to the second power. So not only do we know how to solve these and we want to solve it using integration by parts, we can use a tabular method, right? Because we could just try solving it straight away, but it's u to the second power. That's going to take too much time if we just solve it, the normal way. So why don't we do this? We go u and dv, right? And we say, okay, we have u squared. We differentiate, we get 2u. We differentiate, we get 2. We differentiate, we get 0. Here we just get e to the u, e to the u, e to the u, e to the u. See how nice and easy this is? And so we say that the integral, right, of ln of x dx, oh, sorry, the square goes there, not on the dx. What am I doing? And so that is equal to, and then we have to write all this out. Remember, this goes this way, like that. This is plus, minus, plus. So we have u squared times e to the u minus 2u e to the u plus 2e to the u plus our constant. And then now we just need to plug in, we need to substitute x back in. And remember, I'll just write it right here, u was equal to ln of x. So everywhere we see a u, we need to put ln of x. So here we get ln of x, I'm going to write like this, ln squared of x times e to the ln of x. Well, that's just x. So actually, we have an x out front. Everywhere you see e to the u, that's going to be just an x because you get e to the ln of x. E to the ln of anything is just whatever that thing is. So here we get minus 2 ln of x, but we have this e to the u here, so we get an x from that, and then we get this u becomes ln of x. So then you get 2x ln of x, and then plus we have 2 e to the u, we said that's x, plus c. And then we can just do a little bit of simplification here. We could pull out an x here, right? So we just get that this is x and times ln squared of x minus 2 ln of x plus 2 plus c. And that's our answer. And we see that we arrived at our answer by using U-substitution in combination with integration by parts. And so you want to be on the lookout for that when that might happen. If it doesn't seem like it's possible to do integration by parts straight away, but also it seems like a U-substitution doesn't seem to get you anywhere at first, try looking at using them in combination. Try doing your U-sub and then seeing if that allows you to get anywhere to where you can do a integration by parts application. And one thing I would tell you is sort of the trick to this was realizing here, where going back sort of at the beginning, was realizing when you get this x here that you can solve for that in terms of u, as we did here. We just, we took the antilog and we said e to the u is equal to, x. And so that's how you solve these types of problems. And we use those two methods in combination sometimes, U-substitution and integration by parts.